Okay gang, last video and then we are done with alkenes, at least learning new material. So again, no mechanism here. This reaction is called ozonolysis. And if you're wondering, wow, that kind of sounds like ozone. Yep, ozone's involved. Okay, so let me just give you something like 2-butene, because this is the alkenes unit, right? We're always working with double bonds nowadays. If I were to give you these reagents, and I think I'll make a comment after this, if you put in some ozone, some O3, as well as some CH2, Cl2, and you also toss in some zinc, a second step of zinc, and CH3, COOH, that's acetic acid, right? If you toss in these, some schools, I know at least at Pitt, I think you're allowed to write O3 and zinc. I don't think you need this extra crap, probably just solvent stuff, because I don't know the mechanism. But if you do this, here's what you kind of do. You have to cleave, you end up cleaving this bond. You take the double bond and you cut it in half. One teacher I've TA'd for, her name's Erica Houston, she always calls it that you whip out your molecular cutting scissors and you just cut the double bond. That's kind of a good way to remember it, at least I still remember it like that. And here's what you do. I always like to dot the carbons that were a part of the double bond that I was dealing with. What you do is now we're going to have two products. And here it's symmetrical, right? We have two carbon pieces. And what you do is that carbon that was attached to the double bond, it becomes either an aldehyde or a ketone, which is crazy, right? But since we have two carbons, right, we cut this in down the middle, and this carbon will now be terminal as its own piece, and this carbon will now be terminal as its own piece, right? We will have this type of scenario. We'll produce two carbon aldehydes. Let me show you guys an example where you guys get a ketone. If I were to give you a 6-membered ring with a double bond right here, and I were again to write out these reagents, ozone, CH2Cl2, and zinc, CH3, COOH, a little acetic acid. You see all this? Really, ozone and zinc are the tip-off. Oh, I'm doing ozonolysis. So, get your, whatever you want to get out, your molecular cutting scissors, or I'm going to use this blue marker. Let's cut that double bond. And what I like to do, like I said up here, dot the carbons that are a part of a double bond. So now you can see we're kind of cutting a ring, right? The ring's not a thing anymore. And just to be completely kind of transparent, explicit, we're just going to have one long chain now, right? But I'm going to number my carbons. 1, 2, 3, 4, 5, 6, 7. We're going to have a 7-carbon chain. So I'm just going to draw a 7-carbon chain, fill in my carbonyls where I need them, whether they be an aldehyde or a ketone. 1, 2, 3, 4, 5, 6, 7. Oh wait, 1, 2, 3, 4, 5, 6, 7. There we go. All right. So carbon 2 and 7 are kind of the carbons I'm interested in, right? And you can see that carbon 2, middle of the chain. This is where you get a ketone. All right? So whenever you cleave a ring, ketone probably in the mix. So 7, right? 1, 2, 3, 4, 5, 6, 7. Aldehyde on the end. So really that's all there is to it, guys. You see ozone and zinc, make sure you get your molecular scissors out, you cut the double bond. If it's terminal, right? If this carbon, a part of the double bond, was terminal, make it an aldehyde. If it's internal, it's a ketone. Okay, gang, that wraps it up here for alkenes. We have a few videos for alkynes, and then you're done with OChem 1.